Now we solve exercise 8.1. Question 1. In triangle ABC, angle B is 90 degree, BC is 7 centimeter, and AB is 24 centimeter. Then we will find sin A, cos A, sin C, and cos C. Solution. From triangle ABC, we have AC square equal to AB square plus BC square. From Pythagoras theorem. So AC equal to root over AB equal to 24 centimeter and BC equal to 7 centimeter. So AB square equal to 24 square plus BC equal to 7 square equal to root over 24 square equal to 576 plus 7 square equal to 49 equal to 625 equal to 25 centimeter. Therefore AC equal to 25 centimeter. So sin A equal to, with respect to angle A, sin A equal to BC by AC. BC by AC, where BC equal to 7, AC equal to 25. Cos A equal to AB by AC. AB by AC equal to AB equal to 24 and AC equal to 25. Again sin C equal to, with respect to C, AB by AC, and cos C equal to BC by AC. BC by AC, where AB equal to 24, AC equal to 25, AC equal to 25, and BC equal to 7. Is the required answer. Now we solve the question 2. Solution. Given PQ equal to 12 centimeter and PR equal to 13 centimeter. From Pythagoras theorem, we have PR square equal to PQ square plus QR square. QR square equal to PR square minus PQ square. QR equal to root over PR equal to 13 and PQ equal to 12 square. 169 minus 1, 44. equal to root over 25 equal to 5 centimeter. So QR equal to 5 centimeter. Now 10P equal to 10P equal to P by B, QR by PQ, QR by PQ. Since 10P equal to P by B, here QR equal to 5 and PQ equal to 12. Again 10R equal to PQ by QR, PQ by QR, PQ equal to 12 and QR equal to 5. Therefore cot R equal to 1 by 10R equal to 5 by 12. Therefore 10P minus cot R equal to 5 by 12 minus 5 by 12 equal to 0. This is the required answer. Now we solve this question. Solution. First we consider a right angle triangle where angle B is 90 degree. Angle B, A, B, C. Let us assume a right angle triangle ABC right angle at B. Given sin A equal to 3 by 4. Since sin A equal to BC by AC, BC by AC, that this is equal to K, where K is a positive constant. Positive constant. From this we can write BC equal to 3K and AC equal to 4K. Now from triangle ABC we have AC square equal to AB square plus BC square. So AB equal to root over AC square minus BC square, where AC equal to 4K. So 16K square and BC equal to 3K. So 9K square. This is equal to root over 7K. Therefore cos A equal to AB by AC. AB by AC, where AB equal to root over 7K and AC equal to 4K. K cancel out. We have 7 root over 7 by 4. and tan A equal to P by B, BC by AB, BC by AB, where BC equal to 3K and AB equal to root over 7K. K gets cancel out. We have 3 by root over 7. Let us assume a right angle triangle right angle at B, given 15 cot A equal to 8. So cot A equal to 8 by 15. Since tan A equal to BC by AB, BC by AB, so cot A equal to AB by BC. Since cot A equal to 1 by tan A, cot A equal to 1 by tan A. Let this is equal to K, where K is a positive number. Therefore, AB equal to 8K and BC equal to 15K. From triangle ABC, using Pythagoras theorem, we have AC square equal to AB square plus BC square. Therefore, AC equal to root over AB equal to 8K, 8K square plus 15K square, and this is equal to root over 64K square plus 225K square. And this is equal to 289K square and equal to 17K. Therefore, sin A equal to BC by AC. BC by AC. BC equal to 15K and AC equal to 17K. K cancel out. We have 15 by 17. And sec A equal to 1 by cos A, where cos A equal to AB by AC. AB by AC, where AB equal to 8K and AC equal to 17K. So 1 by cot A equal to 8K to 17K. K cancel out. We have 17 by 8. Now we solve this question. Solution. Given sec theta equal to 13 by 12, since cos theta equal to B by H, so sec theta equal to H by B, equal to H by B. Let this is equal to K, say where k is a positive number. From this we can write a is equal to 13k and b equal to 12k. From Pythagoras theorem we have a square equal to b square plus p square. That is, this is a is b, this is p. So a square equal to b square plus p square. From this we have p square equal to a square minus b square, p equal to root over a square equal to 13k 169k square minus b equal to 12 144k square. This is equal to and this is equal to 25k square equal to 5k. Therefore trigonometric ratios are sin theta equal to p by h, where p equal to 5k and h equal to 13k. K cancel out, we have 5 by 13. Cos theta equal to b by h, where b equal to 12k and h equal to 13k. K cancel out, we have 12 by 13. And tan theta equal to p by b, where p equal to 5k and b equal to 12k. This is equal to 5 by 12. And cosec theta equal to, since sin theta equal to p by h, so cosec theta equal to h by p. This is equal to 13 by 5. Cot theta equal to, since tan theta equal to p by b, so cot theta equal to b by p. And this is equal to 12 by 5. These are the required trigonometric ratios. Now we solve question number 6. Solution. Here you consider a triangle ABC, where DC is perpendicular to AB. So this is angle is 90 degree, ADC is 90 degree and BDC is 90 degree. Let us assume a right angle triangle at B. Right angle at B and DC is perpendicular to AB. Now given cos A, equal to cos B. Now from triangle ADC cos A equal to AD by AC, and from triangle BCD cos B equal to BD by BC, BD by BC, BD by BC. Now interchanging this term, we get AD by BD equal to AC by BC. Let this is equal to K, where K is a positive number. So we have AD equal to KBD and AC equal to KBC. This is equation 1. Let this is equation 2. Now applying Pythagoras theorem on triangle ACD and triangle BCD, we have and now applying Pythagoras theorem on triangle ADC and triangle BCD, we have CD square equal to AC square minus AD square, and from triangle BCD we have CD square equal to BC square minus BD square. This is equation 3 and this is equation 4. Now from equation 3 and equation 4 we have AC square minus AD square equal to BC square minus BD square. Now from equation 2 we have AC square equal to KBC. So K square BC square and AD equal to KBD. So K square BD square. This is BC square minus BD square. This is BC square minus BD square equal to BC square minus BD square. BC square minus BD square and BC square minus BD square cancel out. Then we have K square equal to 1. So K equal to 1. Now putting this value in equation 1 and 2, we get AD equal to BD and AC equal to BC. Since AC equal to BC, AC equal to BC, so angle A and angle B are equal. From this we can write angle A equal to angle B. Since if two sides of triangle are equal, then the angles opposite to those sides are also equal. Now we solve this question. Solution given cot cot theta equal to 7/8. Since tan theta equal to p/p, so cot theta equal to b/p. Let this is equal to k, say, where k is a positive number. From this we can write b equal to 7k and p equal to 8k. Now using Pythagoras theorem, we have a square equal to b square plus p square, where b is base, b is perpendicular, and s is hypotenuse. As this is base, this is base, this is perpendicular. So a square equal to b square plus p square. So a is equal to root over, since b equal to 7k, so 7 square 49k plus p square equal to 8 square 64k square. This is k square is equal to root over 113 k square. This is equal to k 113. So sin theta equal to p/s, where p equal to 8k and h equal to 113k. K cancel out, we have 8/113, and cos theta equal to b/h, where b equal to 7k and h equal to 113k. 7/113. Now question number 1. 1 plus sin theta 1 minus sin theta divided by 1 plus cos theta 1 minus cos theta. This can be written as 1 minus sin square theta 1 minus cos square theta, and this is equal to 1 minus, since sin theta equal to 8/113, so sin square theta equal to 64/113, and cos theta equal to 7/113, so cos square theta equal to 49/113, and this is equal to 49/64. Question 2. Cot square theta. Since tan theta equal to p/b, so cot theta equal to b/p. Here b equal to 7k and p equal to 8k square. This is equal to 49k square 64k square. K square cancel out, we have 49/64. Solution. Given he cot a equal to 4, so cot a equal to 4/3. Since 10a equal to p by b. So cot a equal to b by p. Let this is equal to k, where k is a positive constant. Say from this we can write b equal to 4k and p equal to 3k. From Pythagoras theorem we can write a square equal to b square plus p square. Here b equal to 4k. This is 16k square plus 9k square, 25k square. So h equal to 5k. Now 10a equal to p by b. Here p equal to 3k and b equal to 4k. This is equal to 3 by 4. Cos a equal to b by h. So sin a equal to p by h. Here b equal to 4k, h equal to 5k. K cancel out. 4 by 5. Here p equal to 3k, h equal to 5k. K cancel out. 3 by 5. Now 1 minus 10 square a, 1 plus 10 square a equal to 1 minus, since 10a equal to 3 by 4, 10 square equal to 9 by 16, and 1 plus, this is 9 by 16, and this is equal to 16 minus 9, 16 plus 9, and this is equal to 7 by 25. Again, cos square a minus sin square a equal to, since cos a equal to 4 by 5, so cos square equal to 4 by 5 square minus, and sin a equal to 3 by 5, so sin square equal to 3 by 5 square, and this is equal to 25, 16 minus 25, 9, 7 by 25. Therefore 1 minus 10 square a, 1 plus 10 square a equal to cos square a minus sin square a. Here ABC is a triangle where angle B is 90 degree. Given 10a equal 1 by 3. Since 10a equal to BC by AB, BC by AB, let this is equal to K, where K is a positive constant. From this we can write BC equal to K and AB equal to thrice K. Using Pythagoras theorem we have AC square equal to AB square plus BC square. AC equal to AB square equal to thrice K. So AB equal to thrice K. So AB square equal to 9K square. And BC equal to K. So BC square equal to K square. This is equal to 10K, root over 10K. So sin A equal to BC by AC. Cos A equal to AB by AC. Cos C equal to BC by AC. Sin C equal to AB by AC. Here BC equal K. AC equal to root over 10K. K cancel out. We get this is 1 by root over 10. And this is equal to root over 10. AB equal thrice K. K cancel out. We get 3 by root over 10. And BC equal to K 1. AC equal root over 10. Is equal root over 10. And AB equal 3K. This 3. Now question number 1. Sin A cos C plus cos C sin C equal to sin A equal to 1 by root over 10 and cos C equal to 1 by root over 10 plus sin cos C equal to cos A and cos A equal to 3 by root over 10 and sin C equal to 3 by root over 10 and this is equal to 1 by 10 plus 9 by 10 and this is equal to 1. Question number 2. Cos A cos C minus sin A sin C. Cos A equal to 3 by root over 10 and cos C equal to 1 by root over 10. Sin A equal to 1 by root over 10. Sin C equal to 3 by root over 10 and this is equal to 3 by 10 equal to 0. Here PQR is a triangle where angle Q is 90 degree. Given PQ equal to 5 centimeter and PR plus QR equal to 25 centimeter. From this you can write PR equal to 25 minus QR. From Pythagoras theorem we have PR square equal to PQ square plus RQ square. Since PR equal to 25 minus QR, so 25 minus QR whole square equal to PQ equal to 5 centimeter. So PQ square equal to 25 plus RQ square equal to 625 minus 50 QR plus QR square equal to 25 plus QR square. QR cancel out. We have 625 minus 25 equal to 50 QR. and this is equal to 600 divided by 50. So cancel out, and this is 12 equal to QR. So QR equal to 12 centimeter. So PR equal to 25 minus QR, 25 minus 12, 13 centimeter. So QR equal to 12 centimeter and PR equal to 13 centimeter. So sin P equal to RQ by PR. Here RQ equal to 12, PR equal to 13. Cos P equal to PQ by PR. Here PQ equal to 5 and PR equal to 13. And 10P equal to RQ by PQ. Here RQ equal to 12 and PQ equal to 5. Now question number 10. State whether the following are true or false. The value of 10a is always less than 1. 10a is always less than 1. This statement is false, as 10a can take any real value. For example, 1060 degree equal to root 3. And root 3 is greater than 1. And 1045 equal to 1. And 10135 is minus 1. So this statement is false. Sec a equal to 12 by 5 for some value of angle A. This statement is true, as sec a equal to 1 by cos A. So cos A equal to 5 by 12, which is equal to 0.417, and 0.417 belongs to minus 1, 1. Now cos A is the abbreviation used for the cosecant of angle A. This statement is false, since cos A denotes the cosine of A, and the cosecant is written as cosec A. Cot A is the product of cot A, cot and A. This is false, as cot A equal to cos A by sin A, not the product cot A, cot into A. Sin theta equal to 4 by 3 for some angle theta. This is false, as sin theta equal to opposite by hypotenuse. This is perpendicular by hypotenuse. Perpendicular by hypotenuse. Hypotenuse is the longest side. Therefore, sin theta is less than 1. Sin theta can be less than 1.